Hello and good day, Algebra. We are moving into what should be a review from last year, kind of hitting all the important pieces in this first unit and talking about solving equations. So you've got several equations written down here. Walk me through your process, how you would solve the equation. By solving the equation, we mean solve for the variable, right? What value for n makes the equation work. Think back to last year. What did you do? To solve this equation for n. Great. I love it when no one remembers. No, Paul, here we go. Opposite operations, okay? And what would opposite operations look like for negative 8n plus 11 equals negative 21? Right. You essentially want to undo the equation to get n by itself, because the thought process behind that is if negative 8 times a number, if we add 11 to that equals negative 21, then what does negative 8 times a number equal before we add 11 to it, right? And we can figure that out by subtracting 11 from both sides, because 11 minus 11 cancels that out, and we're left with just that negative 8n. And on the right side, negative 21 minus 11 is negative 32. Okay? Yes. The two key rules for this, opposite operations, and they show you do the same thing to both sides, right? This equal sign is kind of like it keeps the equation balanced. And if we take 11 away from only one side and not the other, our scale is going to go kerplunk, okay? So we have to do the same thing to both sides, undoing what's being done. Nathan?
Are you going to do it more?
I am, because I'm not done yet. Please.
So you divide the negative 8 by negative 2.
Yes.
And then you divide that to negative
yes.
8 divided by negative 32.
Yes, because the operation being done here, it says negative 8 times n. What undoes that is dividing by negative 8, division being the opposite of multiplication. Negative 8 divided by negative 8 cancels out, and negative 32 divided by negative 8 is a positive 4. Okay, positive 4. Yes, sir?
The only thing that I don't get is negative 8 divided by negative 8 plus 1.
Yes. And so what a coefficient tells us, we kind of talk about that down here. What does a coefficient tell us? Like, let's not use negative 8 as an example, because negative 8 is kind of a difficult number to visualize. But let's use 3 here. We'll start this one here. So we're going to subtract 17 from both sides to cancel it out. And we have 3n equals 60. Right? Now, what does that coefficient 3 really mean? Katie?
So it means 3 times n, so
3 groups of n's. 3 n's, right? Whatever n equals, we've got 3 of them. 3n means repeated addition. We have n plus n plus n. We've got 3 of them, right? So if we have 3 of something and we divide that into 3 groups, how many n's are in each group? 1. We have 3 n's. Let's say n equals markers. Got 3 n's here, right? I divide them into 3 groups. How many markers are in each group? Just 1. So when we divide by the coefficient, what we're saying is 3 groups of n is 60. 1 group of n, dividing that 60 by 3, 3 divided by 3 is 1n, equals 20. If 3 n's is 60, 1n will be 20, because 3 20s make 60, right? Of course, we don't write the 1n, because when our coefficient is 1, we don't write it because we're lazy and we just assume it's there, okay? But that's why it equals 1, and that's why it works. We're taking how many n's we have, dividing them into that many groups, and that tells us how many n's are in each group. Does that clarify? Does it make more sense? Okay. The next one says n divided by 5 minus 6.5 equals negative 4.5. What are we doing first? What are we doing first? Caitlin, start with that constant, okay? What is n divided by 5 before we subtract 6.5? Undo that step. Okay? And we get n over 5. Negative 4.5 plus 6.5? 2. Right? And now here, what this is saying is some number divided by 5 equals 2. So what's the process to figure out what that number is? Leah? We're going to multiply by 5. Some folks like to write this out horizontally. It means the same thing, right? N fifths or n divided by 5. That's horizontally, just so they can kind of show they're multiplying here easier. Otherwise, it's kind of awkward, right? The times 5 up here, times 5 up here. I don't know. Either way works. N divided by 5 times 5. You get n by itself. And n equals 10. Okay? That opposite operation method here. Last one, n divided by negative 6 minus 4 equals negative 15. First step. Everybody? Add 4 to both sides. Negative 15 plus 4 is negative 11. Why did I write 16? I don't know. Negative 11. Whether you want to think about it vertically or horizontally, your next step is the same. What are you going to be doing? Nathan? Yep, multiply by negative 6. And n is equal to positive 66. Positive 66. Okay? So there's your crash course in reviewing that two-step equation solving. And really, any equation that you solve comes down to this, right? Whether you're combining like terms or distributing, or you have variables on both sides or roots or whatever, you're working to get it down to this two-step equation where you've got a constant and you've got a coefficient, okay? Let's talk about the roles of each of those things. What's a variable? Define a variable for me. Yeah, and I'll call it the unknown because it's usually a letter, but it can be a symbol. It can be just an empty space, right? But it's usually a letter, but it's an unknown. It's what we're solving for, right? It's the question that is being asked. The coefficient, we already kind of talked about that. The coefficient tells us how many of the variable we have. How many of the variable we have. Okay. Even when we have division here, like n divided by 5 equals 2, how many of the variable do we have here? How could I rewrite n divided by 5 that would show me how many n's I have, like we have with negative 8n and 3n? What's n divided by 5 written as a multiplication expression? Andrea? Paul? No, that would be 5 n's, but I'm taking n divided by 5.
N times negative 5?
Nope.
N times 1/5?
Yes, a fifth of n, right? If I have n and I divide it by 5, that means I have 1/5 of n. And our answer ended up being 10. Isn't 1/5 of 10 2? Okay, so the coefficient, even in a division type situation, it still tells us how many of the n we have. If n is 10, we've got a fifth of that. We're dividing it by 5, and that gives us 2. Okay, the constant is a number without a variable. A number without a variable. You can think about a constant as being constantly alone, just like Mr. Schultz on a Saturday night in high school. But it does not have that variable. It is unattached, unaffected by whatever the variable is or does. Okay? And so it's this understanding that's going to help you with word problems, right? Where you got to set up the equation yourself. So let's take a look. It says you sign up to help a charity with preserving the rainforest. They ask for $20 up front, and then you will give $2 per month after that. Write the equation. How much money will you have given after 6 months, after 8 months, after 2 years? Okay. Now let's pick out the important pieces here. I'm looking for what is my variable, what is my coefficient, and what is my constant. What's the variable? What's the unknown? What changes? What's the coefficient? What's attached to the variable? And then the constant, what is unaffected by the variable? Colin.
Would it be like 2m plus 20?
Okay, so 2m plus 20 is the expression Colin came up here. What's the variable in that expression? The m, right? The month. Okay, why is that the variable? Kaylin? It changes, right? First I ask you for how much will you have given after 6 months? How about 8 months? How about 2 years, right? It's that value in the equation that changes, okay? What's the coefficient? 2. And this one, it doesn't really tell us what we wrote above for how many of the variable that we have. It's a slightly different role here. Whenever you see the word per, each, or every, we're going to be talking about the coefficient. So it tells us what is attached to that month. $2 per month. The word per, the word each, the word every, it means that you are multiplying something. It attaches that value to the variable, right? The more months that you're a part of this, the more money, the more times you will pay that $2, right? So that's the role there. And the constant. What is unaffected by how long you are a part of this charity? Izzy? The 20. You pay that 20 when you sign up for it, and whether you give to the charity for 1 month or 20 years, the $20 that you initially gave is still the $20 you initially gave. Okay, it's unaffected. So 2m plus 20 is the correct expression. And if we want to figure out how much money you'll have given after 6 months, what do? Paul?
You would apply the 6 to
Exactly. Replace 6 with m and solve. 8 months, what would we do? Same thing, except replace the m with an 8. Yeah. 2 years. Maddie? Ah, yes. The sometimes tricky unit change, right? 2 years, since your variable is in terms of months, you do have to rewrite this to be how many months. You would not plug a 2 in there because a 2 would be how many months, right? We want 2 years, which is 24 months. So 32, 36, and 68. What a deal. What a deal. Mr. Schultz has 3,039,001 hairs on his head, and each day he loses 60 of them. Write the equation. How many hairs will he have left after 120 days, 1,580 days, and 50,650 days? Variable, coefficient, constants. What do we got here? What's the expression going to look like? What changes? What is directly attached to that change? What's the rate of change to talk about slope? Bring that word back. And then what's the constant? What's unaffected by what happens? Mr. Anderson? Okay, Paisley? Yes, the variable would be day. Okay? One place to look for the variable is what you're being asked to find, right? 120 days, 1,580 days, 50,000 days, right? Whatever is changing, whatever you're being asked to find, good place to look for the variable. Coefficients. What's affecting the variable? What's attached to the variable? What happens each day that passes, Fultinsky?
The amount of hairs.
Yes, the amount of hairs. And so what would represent the coefficient? And be careful here. This is why word problems can be tricky. This example right here. What number would represent the coefficient?
3 million
So look for those words per, each, or every. Remember, that kind of clues you into the coefficient. 60. Is my coefficient 60?
Yes.
Does that mean I'm gaining 60 hairs each day?
Minus 60. Negative 60.
Why word problems are so tricky. I'm losing 60 hairs each day. My total decreases. It goes down by 60 each day. Therefore, the 60 should be negative. Okay? It's tricky. And then what's my constant? What's unaffected by the number of days, or what do I start with? What's my beginning value? Nick?
Your hair?
Yes, the number of hairs I start with. 3,039,001. Okay, so put this all together. What's the expression? Oh, I kind of wrote the negative 60d. I suppose I wouldn't need the d here. We'll need that with the expression. Negative 60 by itself is the coefficient. But what is the expression? Put it all together here. Caitlin?
3,039,001 minus negative 60.
It wouldn't be minus negative because subtracting a negative is really adding. So just minus 60.
Don't you think it would just be easier to say instead of doing negative 60? Don't you think it would just be easier to say 60? Like just do 60 t's and then just put a minus in instead of saying 60? Negative 60.
So if I read this, I would read it as 3,039,001 minus 60d. But if I ask you what number is this, it's a negative 60. One of the hidden secrets about math that starts to come to light about pre-algebra, algebra time is that this subtraction symbol is also a negative sign. It's a dual purpose. If I ask you what is this number, you tell me negative 60. If I ask you what's the expression, it'd be 3 million blah blah minus 60d. Okay, it's got a dual purpose here. You could also write this to be negative 60d plus 3,039,001. You can rearrange the order of the terms in the expression as long as you keep their signs the same. As long as 3 million's positive and negative 60d, it's going to give you the same result. Okay, some folks always like to have their constant come last, like in slope-intercept form, if you remember that from last year. But the top expression works as well. Okay, so to answer these in the 3 minutes we've got left here, you're going to plug in 120, then 1,580, then 50,650. So how many hairs do I have left after 120 days? How many hairs do I have left after 120 days?
I know all of them, but
3,031,801.
yeah.
Do we have a second on that?
Yeah. Oh, yeah.
1,580 days. How many hairs do I have left then? Paul? Okay.
At 200. It's right. Just add
200.
Just add 201.
Okay. And everybody wants to answer this one. How many hairs do I have after 3,050 days? Everybody? One. And I plan on that hair being really, really long so I can just like wrap it around my head and make it look like I have more. That's my plan for that. Yeah. Pretty soon when I start going in for haircuts, I'm like, just leave one really long. Don't cut them all except for one. That's going to be the one that's going to last me. Okay. All right. Your homework for tomorrow. Number game on the docket. We've got 8 to do here. Work must be shown. Show all of your work. Show all of your steps. And then you've got some word problems at the end there. We are slowly coming up on a test according to our table of contents. We've got one after CO8. We're on PO6. Shh, folks, I'm still talking. So a test is looming. Just know what's out there. Okay, it's coming up after a couple more POs. So homework for tomorrow, finish PO6. That's high math.